Hello students, following questions are common data type questions from topic of effective stress analysis, where it is given that the water is flowing at rate of 0.1 m³ per second in upward direction through fine sand sample whose coefficient of permeability is given, the sample thickness and other cross-sectional parameters, that is its saturated unit weight and cross-sectional area is given as shown very clearly in this diagram. It is asked in first question, that is question 48, that what is effective pressure at midsection of the sample. This is a very easy question. If you remember the formula for effective pressure, it is given by gamma dash Z minus Iz into gamma W, where I is hydraulic gradient, which is given from Darcy's law as Q upon Ka, where Q is discharge, K is permeability and A is cross-sectional area. Everything being given in centimeter cube per second. The value of I comes out as 0.25. Here don't get confused with the calculations. I converted all the values to m cube, all the length dimensions to meter first of all. That's why it's looking little bit absurd. But since all the values are given in centimeter and seconds for length and time respectively, you can directly substitute the values of Q, K and A from the question, from which I, that is hydraulic gradient, comes out as 0.25. Now since seepage is taking place in upward direction, if we talk about mid height, since seepage is taking place, so soil mass is submerged and hence the effective pressure at mid height will be gamma dash Z, that is because of soil, minus Iz gamma W, that is happening because of this seepage pressure. And when this equation that is marked by 1 is become equal to 0, and in that case the value of I so obtained is called as critical hydraulic gradient, and we study that phenomena as piping or quicksand condition. But here we are not concerned about those phenomena. We are just asked about what is effective pressure at midsection. So we'll be using this formula. So at mid height, 90 minus 9.81 into 5 by 100, because it is having the height of 5 centimeters. Since Z is 10 centimeter, Z by 2 comes out as 5 centimeter, minus I, that is 0.25, into Z, that is 0.05, into gamma W 9.81, which comes out as 0.3369 kilonewton per meter square, which is closest to option C, which is 0.34 kilonewton per meter square. Hence correct answer for question number 48 is option C. Thank you.